Okay, we're going to do a couple of application of quadratic functions here. And these will involve maximum or minimums. Now remember, the maximum or the minimum is going to be at the vertex. So we'll actually be able to use the vertex to solve this. So it's number 1 says a stone is thrown directly upward from a height of 20 feet with an initial velocity of 50 feet per second. The height of the stone t seconds after being thrown is given by s of t equals negative 16t, this should be t squared, plus 50t plus 20. So the important thing here is our function is negative 16t squared plus 50t plus 20. So it determines when, it says determine when the stone will reach its maximum height. That will be the t, the x coordinate of our vertex, and what the height will be, and that will be the y coordinate of our vertex. Okay, now remember, to get our vertex, to get the x coordinate, or our t here, we want to do negative b over 2a. So we'd have negative 50 over negative 16 times 2, 2 times 16. And there, applications we normally do as decimal, so we'd get 1.5625. So if we rounded 2 decimal places, seconds. And to get our height, we want to plug that in. So we want what s of 1. Let's go ahead and use the whole thing, 25. 1.5625 is. Okay, and you can put that into your calculator. So negative 16 times 1.5625 squared plus 50 times 1.5625 plus 20. And here we get that this is 59.0625. And this would be in feet. Okay, so the time here was 1.5625 seconds. And the maximum height was 59.0625 feet. Okay, let's do one more. So this says 2 adjacent dog runs will share one wall. If 300 feet of fencing is available, what dimensions would provide the maximum area? Okay, so here we're going to have to set up the quadratic function and then find the vertex to find the maximum. So we've got this rectangular here that's making the dog runs, and to make it 2, we have this one shared wall. Okay, so we have, let's label this x, 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 and we'll label this y and y. Now the maximum area here is going to be x times y, so our area here, we want x times y. Now how can we put this all in terms of x? Well, we know that if we add all of this up, we have 300 feet available. So if we do x plus x plus x, or 3x plus 2y equals 300. So if we want to get this in terms of y, we could say, okay, well, 2y equals 300 minus 3x, if I subtract 3x from both sides, and then I'm going to divide both sides by 2. So I'd say, okay, y equals 150 minus 3/2 x. So I'm going to plug that in for y. So our area in terms of x is equal to x times 150 minus 3/2 x. Now we can distribute that x. So we'd have 150x minus 3/2 x squared. Now I'm going to rewrite that just so it's in descending order. So we'd have negative 3/2 x squared plus 150x. So if we want to find our maximum area, first we need to find our, we're going to find our x which will be our kind of length here, and then we can use that to find our y. So to find our x of our maximum, which would just be the x coordinate of our vertex, so we need to do negative b over 2 times a. So here we'd have negative 150 over 2 times negative 3/2. And if we reduce that, we get 50. So here we're saying this is 50, this is 50, this is 50. Well, if it was 300 total, we can plug in 50 for x. Or here, we can solve for y here. So y equals 150 minus 3/2 times 50. Which gives us 75. So our dimensions are 50 by 75, and these are feet. Now to find the maximum area, well, you could do 50 times 75, which would give us 3,750 feet squared. You could also plug the 50 in here and find out your maximum area based on the vertex. They would give you the exact same answer.